think these big grants, what it brings, the ability to collaborate with others with different skills. For example, people with modelling skills together, people with experimental skills, and then the sum of the parts is much greater, and you have much more chance of solving the problems that you're trying to solve. It's very difficult because when you look at a lump of metal, it looks like a grey lump of metal, doesn't it? And it's very difficult to get across to people how many different properties there are in steels. I mean, I think there's actually a list of nearly 10,000 different grades of steel on the book. I always say it's a bit like making a cake. You know, you can make a variety of different cakes with a variety of different flavours and so on. You put lots of different things in, and we do exactly the same with steel. Really, it is cooking the steel with a lot of different elements, all do a specific job within that structure and end up with the properties that you want. The way that most steels are done is that you change the composition to get a steel grade that the customer wants. It would be much more efficient if we could reduce the number of compositions that we make, and then later in the process route, by changing the way we deform the metal and heat treat the metal, that we could have a range of properties out of one composition. So that's quite a challenge, but clearly it would be much more efficient if we could do that. Although we've been working on hot deformation for a long time, there's been huge amounts of research done, there's still scope for looking at the way that we sequence the deformation modes during rolling or forging, and of course subsequent heat treatment. And in fact, we can change those properties quite significantly.